Hi, this is VK4GXC, and again with another one of the older vintage radios which I've recently restored. This is a Siemens E311 version E, one of the later units. It has a 100 kilohertz lock feature on this, which is allowing it to incrementally lock at 100 kilohertz intervals and then use an interpolation oscillator to dial in the last few kilohertz. The receiver was designed in, I believe, the late 50s. Went through a number of iterations, and for A, B, C, and then finally the E version, which is this particular unit. It is a valve system on board here, and there are some hybrid circuits in there, some transistors on the switching side of it. All the RF strip is basically in a valve design. It uses a lot of ECC, in fact EECC 82 double triodes, which are becoming fairly expensive now. And fortunately all the valves in this set are good, but yeah, the prices on those seem to be driven by the audio collectors group at the moment. Having said that, this receiver does seem to run very well. There were a number of issues with this particular receiver when I first got it. The thermostats, which are governed internally by two circuits. There's a 100 kilohertz thermostat here, which is embedded in the main module system in the rear, and there's also a VFO, basically a thermostat here. The ovens are not particularly, I don't think particularly well designed, to be honest. There's a lot of thermal leakage, should we say, on them. They're not very well padded and insulated. The VFO thermostat here takes up to half an hour to start to stabilize, and is really not useful in its full sense until about an hour into the set's operation. The main 100 kilohertz like comb generator reference seems to stabilize somewhat quicker. Anyway, a bit of a quick tour on the front panel. There's basically an audio gain pot here. You can pull to hear the onboard speaker. Currently I have an alternative external speaker fitted. Above that is the bandwidth selection. We're in a single sideband mode at the moment, so it's actually inoperative, but if we went to something like AM, you can hear it going through the 3, and also for CW you can hear it go through the narrowband. Now the filters are down at 30 kilohertz, which is the final IF, and they're all LC style of filters, so it's a little bit broader than you might want to be expecting for a set for today's use. But having said that, it does give remarkably good audio output, even it being a little bit wide. There's an onboard noise limiter, obviously an onboard speaker. There is a indicator here which indicates when the 100 kilohertz marker is actually locked up. So there's a coarse and fine tuning. The coarse tuning here allows you to go to various. If I try and get in between, you'll see it will tick. Well, let's actually try to lock in there. It will tick as you go between two 100 kilohertz sections. And again, you can probably hear it just moving around. So it locks at each one. The mode operation switch is down here. Again, there's a cal feature which allows you to zero it to the nearest 400 kilohertz. I've not really found much use for that. It seems to be working quite well. Obviously a couple of fuses. The sync, there's an option for a 1 kilohertz sync on it. This particular set doesn't have it. I don't think many did have it. AGC, which is basically off. 0.2 and 2 seconds. There's a squelch feature which I think is pretty much not used, mainly for AM many years ago. Obviously an upper and a lower sideband, which is very nice to have on a set of this type. And RF gain. Above the RF gain is the fine tune. Now this is what they call an interpolation oscillator. You can see it moving the kilohertz dial here. It's a bit of a free running arrangement here. Needs a little bit of oil on the gearing system. Interesting meter. It's not an S meter. It's really just a coarse sort of signal strength meter, and it doubles as an audio output meter as well. So if you set the audio up, it moves around. There are actually 5 independent bands. It tunes 1.5 to 30 megahertz, and obviously it's dependent on which band you've selected. Very common mode of moving around a turret internally, and a dial block and window on the front there. So there you go. But if you're stuck between two of the 100 kilohertz markers, you'll see it will tick, and if you go to the nearest one, you'll be able to zero it down. There is a slight correction required. I noticed that the main gang tuning arrangement is just 4 variable capacitors all ganged up together, as fairly traditional with a lot of sets of this nature. A couple of RF stages, a mixer, and then the IF out. As you go down the lower frequency, it does seem to require a bit of a manual tweak, and I think that's normal. I think there's nothing wrong with that, and you've got quite a lot of range on this. And as I say, it really is set to offset the IF, the tunable IF bandwidth, because as you go down to the lower frequencies, you find it does actually, how can I put it, become quite peaky. Anyway, there's an array of different outputs, line output, speaker. We've got a speaker plugged in externally out of shot here. There's a headphones and a long wave or long wire adapter. I'm not quite sure what this is for. This is the IF out here. I think this is for the 10 kilohertz to 1.5 megs VLF adapter. General condition when I got it, both the ovens were broken. The escutcheon plate here was heavily kind of corroded, really, best way I could describe. Bit of cleaning, back to bare metal, refill, colour match. What else is wrong with this? Yeah, a couple of relays weren't ticking over like they're supposed to, but fundamentally it was sort of operating. There's a very difficult way to realign the main first local oscillator, and it utilises a couple of apertures in the front panel here, and you need to insert a tool, and that tool is it's very specific to the receiver, and there's some diagrams kicking around. I had a couple of them made up. One of them fitted, one of them wouldn't. However, having said that, there was enough play left on them to align to the nearest 100 kilohertz markers. So right now the whole receiver tracks on all bands to the 100 kilohertz markers, which I think is probably not normal. I think there's a lot of them which probably don't do that at the moment. And I'll give a bit of a show inside in a moment, but let's have a quick tune around the band and see what we can find. It's actually Good Friday, and it's in the afternoon, and we're in Australia, so let's just see what we can find on the higher bands, perhaps on 20 meters. So we'll go to 14.2, and then we can tune around 200 plus. I'll just make sure it's peaked. We'll just turn the volume up a bit. It's much higher frequency hiss than normal. I think it's just 3.5 kilohertz SSB bandwidth. So this is Bulgaria. All the connections are on the front panel, which is good and bad. It makes it a little bit more busier. The antenna comes out on an SA259 on the front here, and as all the speaker connections, there's nothing on the rear panel. The whole receiver is designed to sit into a case. Let's see what else we got there. Again, if you're considering purchasing one of these receivers, they're generally easy to work with in terms of modular construction. I suspect that a lot of the common faults are to do with the heaters for maintaining the temperature internally. You probably could do without them. I'm a bit of a purist, so I've gone in there and reworked the how can I put the sensors in the circuit. There was a transistor blown on one and a relay issue on another. And this now gives me both these ticking on and off. In fact, if one of the relays goes, in fact it's this particular relay which heats up the interpolation oscillator, actually, and if that relay goes, you will have permanent heater. It doesn't even switch off. So be advised that you should check this 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 lamp out, because if it is on permanently, you're just continually heating up the VFO, and I don't think that does good for longevity or MTBF long term. Anyway, I'll just go back to having a bit more of a tune around. It's surprisingly accurate, to be frank. Once this is all warmed up, it's within 50 Hertz, and the resettability across the whole 100 kilohertz is within 50 Hertz. Let's see what else is on the software. A few birdies. Not from the receiver, it's locally, some computer noise. Sophia station. Something a bit stronger. We'll just drop down to 14.1.
Yes, definitely. And I thought of something then, and I should have written it down because now it's gone straight out of my head. What was I going to ask you? Oh gosh. No, I can't think what it was. It'll come to me. But yeah, you're obviously in a nice little spot there, and a good signal, and good to hear you on. Oh, I know what I was going to say. I wondered if you know what your Shire and your grid square are. I wonder if you know what they are, because even the locals would be interested in collecting those, Joe, over.
I'm not sure, Lynn, but I'll be here for a little while, and I'll get back to you. You mean the ones I'm at right now? Well, the Shire would be, well, it's about 25 kilometers southeast of the city of Mildura, so I'm not sure what the Shire is. Obviously, maybe Mildura has a Shire. I don't know where the grid square is, but I can't look it up fast on whether you get internet connection here on anything other than Optus. It's pretty hopeless. So the iPhone won't work here. It's on Vodafone. That's the one that works. But I have a new Android from an Aldi Android, which works reasonably well on Optus. And I don't know if you know about that system link, but it's really good. You can call a mobile anywhere in the world, and particularly in Ireland, you can call a mobile on that.
Yeah. Obviously the usual problems with people tuning up on frequency. Feel sorry for the guys.
I just missed the name of the system. What was the name of the system you were talking about?
I'm using an Aldi mobile system, just one you get from Aldi.
Oh, please. Just trying to work out where these couple are. One is down in Mildura in Victoria. I'm not sure where the lady is.
Goodness, that sounds fantastic. Oh, good stuff. No Aldi shops up here, of course, but I know what you mean about the different...
I guess she's in Queensland.
The same thing up here. If anyone turns up here with an Optus phone...
Let's just see if there's anything else. Okay. No, it's getting a bit quiet. There's only CW going, first of all. No. It's going to give a bit of a demonstration of the CW filtering. It's quite nice. Also should go through to the higher frequencies. Let's go to 15 megahertz. I'm not sure if... No, they've gone off. And we'll also try We'll also try just trying to see how there we go. This is Radio National Australia, and extremely strong today. So that would be 15.240.
So therefore, they may still accommodate from the international flights, except for the others who are leaving the small flights further.
Realistically, like one time, you think this workload airport is finished.
So it sounds like they're speaking a form of pidgin English.
Public, more the travel agents, more everyone.
And we'll just see what WWV is coming through like, shall we?
After 10, 6 hours, 45 minutes, coordinated universal time.
Somebody come through from Hawaii. It does give an idea. We're in Brisbane, so it's a few thousand K. I'll just so we can peek it a little bit. Okay. And one of the other frequencies I tend to use just to test out the receivers is the aeronautical frequencies. So we'll just drop down to the aeronautical band. Let's see if we can find somebody on a couple of frequencies I've found recently quite active. We'll try good old at 867. Now, because this isn't fully warmed up, we'll be a few hundred hertz high. We'll just park there a short while to see what, see if anything comes up. It's Auckland control, they're quite quiet in the background. Okay, let's just drop down a little bit further. See if we can hear any of the volmets. No. And one last frequency I tend to use, really on timing. No, there's nobody there. It's one of the maritime weather report stations. Okay, so here it is, the Siemens. It's a pretty nice receiver, actually. I guess it's long in the tooth by today's standards. Certainly adequate. Very, very stable. In fact, it's probably one of the most stable freewheeling units I have here. Once the ovens are warmed up, you can be the set abilities within 50 hertz comfortably, and I'm quite impressed. Impressed that it just sits there. So I'd imagine once it's switched on, minimum early in the morning, leave it on all day, you just always be on frequency. The single sideband is slightly wide, but it does give you a nice fidelity to the audio. Let's go back to 20 meters perhaps, and we'll just you can see it locking on the various. So we go back to 14100, we're on upper sideband. Okay, and we'll just have a little tune. Let's see if something else. Okay, well, I'll give a bit more of a tour of the receiver inside. So we'll just turn the audio down a bit, and I'll move the camera. So just starting from the front panel and having a look, you can see that there's the what's it, the mileometer gauge, the odometer, and it tells you the frequency. Very nice, very smooth. Above it is the main megahertz dial, so you can see that that works on junction with the lamp on the left, so that it shows when it locks. Okay, and again. So it ticks through all the different 100 kilohertz. Now as we look into the main unit itself, and I've got a little lamp here, so I'll just try and illuminate a few things. On the left is the main power supply. Here's the SSB final IF. There's the two crystals for upper and lower sideband. The next block across, this one here, it's actually is housing the 100 kilohertz like raster generator they call it, which is generating the comb generator to be able to lock to your 100 kilohertz steps. To the right of that is part of the mixing, the mix down, first and second mix I believe, and then on the very right here is the 2 RF amplifiers in the first mixer, and this whole module drops down probably about 4 to 6 inches below this with quite a large ganged tuned capacitor. It's quite impressive. Aligning this is quite tricky, be advised. I don't think a lot of this is for the newbie. There's some overcoupled filters here, and you've got a main front pre-select of course, and a post-IF, post-mix output there. Now down the main front panel section here, you can see the mechanical nightmare and all the adjustments and trimming and tuning going all the way along. The speaker, it's a nice internal speaker, it's quite crisp. And so just coming back to the front panel, just wanted to show you this business down here. So you can't really see because the light's not there. You see those two covers there? That is to allow you to set the trimmer and padder on the first local oscillator, which in turn allows you to set up the tracking on the 100 kilohertz markings on the upper dial on here. Now that is a bad design. It's a nightmare. Special tooling required. If you don't have the special tooling, you have to rip the outer front panel off and the inner front panel off, and you still have to make up some kind of special tooling to still get into these two trimmers. This is typical of like Volkswagen spark plug type adjustments, so that is something to be wary of, and it's taken me quite a while to be able to get some tooling made up to try and get that right. But all in all, once the receiver is functional, it's very nice indeed. One moment, there it goes. Wasn't locking in there. Once it's tuned up, I got to tell you, it's a very nice receiver. It's the only non-Anglo or USA receiver I have, and I'm very impressed with it, to be honest. For its time and its design and its size, very impressive. I've got RA17s here and obviously R390s. Slightly different approach, slightly different concept. Modularity, yes. Quality of components and choice, probably as good as they could have got, but it does miss some of the higher quality mill standard parts I'm used to seeing. And having said all that, though, the sort of faults I've been getting have been mainly mechanical and the odd blown transistor, to be honest, embedded in the oscillator, in the 100 kilohertz oscillator. So, one last thing I should mention, the set itself has a mains power supply built in, of course, and that is adjusted down here by these, there we go, by these jumpers. And as you can see, it's 125, 110 and 220. Well, 220 is nominally the highest voltage you can set this to in the stock form, and there is a way around that. We run obviously in Australia 240, and when I was measuring the voltages on this set, I found them significantly higher, 10-15% higher than they should be. So I had to rewire the transform on the mains. There is a little bit of information on the web about this as well, and basically it's just tapping into two of the extra 10 volt taps on the mains input. And now it's all running exactly where it should do. All the voltages are right. There's a 150 volt stabilized supply at the back here, and that's adjustable. It's quite impressive. It's a little adjuster at the back, and yeah, that gives you the stabilized supply, the temperature stabilized oscillators. The whole thing is was obviously designed to be set and forget on frequency. And of course, as most maritime receivers have, we've got these locking bars here, which will allow you to lock the actual main tune, just for those rough days at sea, I guess. Anyway, I'll leave those off for the moment. So there we have it, the Siemens E311 variant E, and yeah, I think at some point if we ever get hold of the 1 kHz add-on, it'd be nice to actually experiment with that too. Anyway, thank you for watching, and I hope you keep in touch with all the receivers I have here. This is VK4GXC. I just wanted to give you an idea of what the antenna base is here for doing the test this afternoon. It's a loop antenna, own design. Comes through a balun and a high dynamic range, low noise active amplifier, sorry, pardon, and that feeds obviously the antenna down here of the receiver. Measurements of this antenna shows me that the difference between an active wideband loop antenna, with the right amplifier that is, and a tunable non-active tuned antenna, this particular antenna is within 1 dB of a normal passive free-tuned loop. I'm not sure if that comes across very clear, but what I'm trying to say is this is actually a wideband antenna which gives the same performance as a tuned loop antenna across the full band. So in essence, if you were to have a multi-coupler connected to this, you could have a number of receivers all tuned up, with the loop antenna here actually providing a near resonance for all receivers. Anyway, just something I wanted to add in there.